This is 2.5, equivalent statements, part 1. So, two statements are logically equivalent if their truth table values are the same. So we see the symbol here, and it looks like an equal sign with an extra line underneath it. That means two statements are logically equivalent. So we'll use that symbol to utilize when we're talking about two things that are logically equivalent. So for instance, it says to show that if P then Q is logically equivalent to negation Q then negation P through the use of truth tables. In order to do this, we must create truth tables for both if P then Q and negation Q then negation P. All right, so I'm going to work on the left-hand side. So this is if P then Q. And we're going to work on the truth table here. So we have 4 rows. And we know that P is always true, true, false, false. And Q is true, false, true, false. So if true, then true gives me true. If true, then false is the only time this is false. If false, then true is true. And then if false, then false is true. Again, the only time that the conditional is false is when you start with something true and back it up with something false. So these are my truth values. True, false, true, true. All right, so let's look at the other side. I'm going to do that in green here. We're going to do negation Q, then negation P. So again, 4 rows. And P is true, true, false, false. Q is true, false, true, false. Negation Q, I look at the Q column and I write down the opposite. So negation of true is false. Negation of false is true. Negation of true is false. And negation of false is true. Negation of P, I look at the P column and negate it. So negation of true is false. Negation of true is false. Negation of false is true. And finally, negation of false is true. So if I put the pieces together, I do negation Q, which I found to be false, true, true. Put the symbol. Remember, we're doing if then. And then I'm going to do negation P, which was false, false, true, true. Now I'm going to look at the results. Again, this is a conditional. The only time the conditional is false is when we start with something true and back it up with something false, which we see in line 2. If false, then false is true in line 1. In line 3, if false, then true is true. And in line 4, if true, then true is true. So my truth values for negation Q, then negation P are true, false, true, true. Now notice that I have exactly the same truth values in exactly the same rows. In row 1, if P, then Q, and negation Q, then negation P is true. In row 2, it's false. In row 3, it's true. In row 4, it's true. So again, the truth values have to be the same for both. Okay, so we can conclude that the conditional, if P then Q, that's called the conditional, is equivalent to if Q then P. We don't know this one yet, but it's called the contrapositive. And they are equivalent to each other. So the conditional is always equivalent to the contrapositive. And like I said, we're going to go into more detail about these statements at a later time. All right, so let's look at this statement. Negation of if P then Q and P and negation Q, are they equivalent? So the truth table is already done for us. So if we look at the first one, we get false, true, false, false. And if we look at the second one, we have false, false, true, false. So again, the rows have to have the same value in the conclusion. So if we look at it, in row 1, negation of if P then Q is false. And in row 1, P and negation Q is also false. However, in row 2, negation of if P then Q is true. And in row 2 of P and not Q, we have false. So they don't line up, so therefore they are not equivalent. Okay, so when that happens, it's not equivalent. Okay, so it says shows that the negation of P and Q is equivalent to negation P or negation Q through the use of truth tables. All right, so again, 4 rows. I'm going to focus on the left-hand side here. So I'm doing negation of P and Q. So P is true, true, false, false, and Q is true, false, true, false. We're going to do an and now. So rewrite down the P column because it's P and Q. True, true, false, false. Get the and symbol in there. And then we do the Q column, which is true, false, true, false. Okay, we're looking for the result. And I almost screwed that up, so I got to fix that. All right. Remember, it's an and. The only time and is true is when both of them are true. So in line 1, it's true. Line 2 is false. Line 3 is false, and line 4 is false. Now I'm going to negate what I just found. So I just found to be true, false, false, false. So negation of true is false, negation of false is true, negation of false is true, and negation of false is true. So the truth values for negation of P and Q is false, true, true, true. Okay, let's do the other side. Negation P or negation Q. So again, 4 rows. P is always true, true, false, false. And Q is always true, false, true, false. So I'm going to negate the P column. So negation of true equals false. Negation of true equals false. Negation of false equals true. And negation of false equals true. I'm also going to negate the Q column, which is negation of true is false. Negation of false is true. Negation of true is false. And negation of false equals true. So now I'm going to put together the pieces. So I'm going to write down what I just got for negation P, which was false, false, true, true. I'm going to put the or symbol. And then I'm going to put negation Q, which was false, true, false, true. And it's an or. The only time or is false is when both are false, and we see that in line number 1. So false or false is false. In line 2, it's true because false or true is true. In line 3, true or false is true. And line 4, true or true is true. So the truth table values for this one are going to be false, true, true, true. Now if I compare the two, line 1, they're both false. Line 2, they're both true. Line 3, they're both true. And line 4, they're both true. So therefore, they are equivalent. So we can say negation of P and Q is equivalent to negation P or negation Q. By the way, this is known as the use of De Morgan's law. And we're going to see more about this in the next section. But if you think about it, if I negate P and Q, if I distribute the negation, here's what happens. I get negation P, flip over the and to or, and negation Q. So that is the use of De Morgan's law. Again, the directions specifically said to use truth tables, so that's what we had to do. All right. I'm going to stop here, and I'm going to do a part 2. And we're going to start off with this you try it. So, before you start watching the next video, why don't you go ahead and give it a go. Do 2 truth tables to show or to see if negation of P and Q is equivalent to negation P and negation Q. All right? Thank you so much for watching, and please watch the next video.